Okay, Assalamualaikum and salam sejahtera. Okay, now we are going to go through this example, okay, for the second session of my tutorial class. Okay, I give you 1 minute to go through this, to read this example statement, okay. So, in this example, okay, we are dealing with mechanized production process. We have a ball bearing move on a horizontal track, okay, with the acceleration of a equal to kx meter per second square, where x is in meter. Okay, x is in meter, right? The ball bearing would then reach NB, okay, reach NB and fall through 100 millimeter diameter. Okay, hole. Oh, okay. So knowing that A 1 meter per second square and x equal to 0.25 meter, so you need to find the range lah, the range of you if the ball bearing were to enter the whole CD. So to get the point lah. Okay. Kalau tak masuk, okay lah. Oh, dia ajar main game lah ni kan. And then the corresponding time from B to whole CD, what will be the flying time? Then what will be the corresponding range of D? Okay. Required. Okay. All right. Okay. So you still remember the important equation? Okay. We talk about here. We have, when we talk about projectile motion. Okay. Projectile motion. Okay, we are dealing with X motion. Okay, and Y motion. Banyak student dia terima apa-apa je kadang kan. When we talk about this equation, basically it's just simply take it from your textbook lah. Okay, from your textbook, how to get the value kan. So we have here, when we are dealing with projectile, we have this equation X, which is X double dot is 0. Okay, and then we have Vx, and then we have Vy. Okay, Vy. We have Vx, we have X. Sorry, we have X. We have Vx, we have X. Okay. So here Vx, and so we have X. Cuma this one Vx ni basically is X dot. Okay, X dot we have to is basically Vx x0, and then X is basically X dot, okay, plus Vx times T. Okay, because the projection ni, the projection start macam ni. Okay, kalau kita ambil this one as a datum kan, take this one as a datum, we project here, we have angle. Okay, this is datum. So from here this is Vx, and then we have here Vy kan. This is initial, this is Vx, and then this is Vy. Okay, we take datum X, this is Y. Okay, so you must start from here, and then when we say about Vx, ni, this one relate to this figure. Maknanya we have to write in term of cosine lah. So V dot cosine theta. Okay. And V dot is initial velocity. Okay, this is for X motion. Okay. So my experience benda ni pun student tak boleh nak buat. Kan? So I want you to make sure you understand this one. Okay. Before we do this. And then for Y pula, Y motion, we talk or we are dealing with uniformly accelerated motion. Okay, uniformly accelerated motion. Jadi semua formula yang saya cakap tadi tu kena relate lah. Okay, contoh. Contoh ayo different color. Okay. Okay. AY. Okay, AY. What is AY? AY is Y double dot. Okay. Sebab yang ni kita lambung bola ke atas, so dia akan ada gravity kan. So equal to minus G. Okay. Minus gravity. Okay. Vy is Y dot. Okay. Okay. Y dot. What is Y dot? Y dot is Vy dot minus. Okay. And then another formula we have to use Vy square equal to Vy dot square. Okay. Minus 2 minus 2G V square plus U square plus 2AS kan, ingat formula dulu kan. So this one Vy minus 2Y dot, right? GS. Okay. S here is Y minus Y dot. Okay. Okay. So Vy dot, so Vy dot is basically what? Like tadi cosine. So this time is V dot sine theta. Okay. Ini penting. Okay. So we proceed to solve this problem. What is the solution of it? By knowing all of this, by applying all of this into this question, so we start with the first one, maximum U. Kita kata tadi, maximum U soalan tadi. Maximum U when the bearing hit ND. Okay, maximum U ni untuk dia hit ND ni. Okay, maknanya X equal to 0.4 meter, and then Y. Nampak ah? We have the datum here going down. Datum going down. Ini datum positive going down. So we have here Y equal to minus 0.180. Nampak ah? We convert millimeter to meter kan? Alright, this is one. So maximum hit kat D. Minimum hit at C. Okay. Minimum at C. Kalau C, berapa C? X equal to, kalau tadi 0.4, 0.4, this time here lah. C from here. X equal to 0.3. Okay. 0.3 meter. Y equal to, sama lah. Minus 0.14 meter. Okay. Alright. Now you start to find the uniform motion in X direction. Okay. Uniform in X direction. So uniform X direction. I use different color. inform x direction. Okay, in this case v dot equal to u, okay, and theta equal to 0, right? Theta 0 kan, mana ada sudut apa kan, sebab dia terus jatuh lah. Kalau yang macam tadi ni we have theta kan, so this time theta 0. Okay, so you find or you use this equation lah, this one. So you dapat Vx equal to V dot cos theta, okay, equal to U. Okay, so I name this one equation 1. Okay, and then for x pula sama tadi lah, guna yang tadi x, this one lah, x equal to, okay, 0 plus u, okay, origin b. Okay, this one equation 2. Same thing for y lah, okay, for y, same thing for y. So you solve for y as well. Tadi untuk x direction, untuk y direction pun same thing. Okay, you apply equation yang cosine tadi, which is this one, sine tadi, pakai yang ni. And then you use equation y equal y dot tu kan, y dot plus b sin theta, okay, b sin theta, okay, you use this one, I write it down for you, y equal to y dot plus b dot sin theta, okay, sin theta b minus dt square, okay, so we name this minus dt square, okay, and then you start to solve and get the value of u equal to, okay, you solve and then you get the value of u equal to 1.57 meter per second, then t equal to 0.19 second. This one you can try, can try. I just give you the answer. Okay. All right, time's already 12:08. So I think I'm going to stop here. Okay. Next week we're going to do a few more examples. Okay, to strengthen your the topic of kinematic of particle. I'm going to stop here. Before stop sharing. Okay, I'm going to share the attendance list in our WhatsApp group. Okay, so I think that's all for today. So I'll see